The next reporter will follow. Thank you.
Good day, everyone. My name is Joe Canabi, and now I'm going to continue our report. Okay, so here for the illustration 3 to 4, from figure 3 to 7, determine the number of 12 millimeter steel bars required if there are 6 footing with general dimension of 1.50 by 1.50 meters. So this is our figure 3 to 7. This is the dimension of our what do you call this one? Our footings, and this is actually the net length of our one bar, which is 1.35 meter. So first, this is our solution. First is to determine the net length of one bar, which is 1.50 minus 0.075 plus 0.075 equals 1.35. So next is to find the total number of cut bars in one footing by direct counting. So by counting here, we have 13. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is what we call the direct counting, and then multiplied by 2, so we have 26 pieces. So the third step is to get the total number of bars for the 6 footings. So we have 26 pieces in every footings, and we have 6 footings. So 26 was multiplied by 6, so we have 156 pieces at 1.35 meter long. Since our steel bar, the length of our steel bar is 1.35 meter long. So for the fourth step, we have to select the steel bars whose length is economically cut into 1.35 meter long. So here, the 6 meter was divided by 1.35, which is equal to 4.44 pieces. So the fractional value of 0.44, since the answer is it's a fractional value, so 0.44 is inevitable but should not be included in the computation because it is less than 1 cut bar length. Use the whole value of 4.0. So accordingly, we don't need to use this 0.44, so we will use this as a whole value, so we will use 4. So next is to divide the result of step 3 by 4.0. So the result of our step 3 is 156. So our 156 was divided by 4, so we have 39 pieces of 12 millimeter by 6 meter. So we need this 39 pieces of our steel bar, which is 12 millimeter by 6 meter. So the common error committed in estimating the number of steel bars is presented below here. So using the same data, the net length of one bar is 1.35 meter, and the total number of bars in one footing is 26. And then the total number of bars for 6 footings is 156 pieces. Then the total length of the bars in meter, which is 156 times 1.35, is equal to 210.6 meter. Converting this steel bar length, so we have 210.6 divide 6, so we have 35 pieces. So as you can see, the answer of the first solution has a difference. They differ in 4 pieces because our answer here is 35. So comparing the result of the 2 estimating procedures, the answer has a difference of 4 pieces, as I said, steel bars at 6 meters long. This is the result by including the fractional amount of 0.44 as divisor of the reinforcing bar net. So the second procedure could be correct if the quotient in dividing the length of one bar by the length of one cut bar yields a whole value. On the contrary, if the result has a fractional amount, the second procedure will not give a correct answer. So the following illustration is an example where the second procedure applies. So here for the illustration 3 to 5, from figure 3 to 8, determine the number of 12 millimeter steel bars and the tie wire in kilogram if there are 20 pieces independent square footing with general dimension of 1.15 by 1.15 meters. So this is our illustration, the figure 3 to 8. These are our steel bars, and this is the dimension of our, I think it's column. Yeah, I think so. It's footing. Sorry. So this is the net length of one reinforcing cut bar is 1.20 meters. So first step, determine the net length of one reinforcing cut bar. So we have 1 meter plus 0.20 meter is equal to 1.20 meters. So this is our net length of one reinforcing cut bar. So the total cut bars in one footing is we have 6 times 2, since this is actually a direct counting again. So we have 1, 2, 3, 4, 5, 6. So 6 times 2, so we have 12 pieces. So we have total cut bars for 20 footings. Since we have 20 footings, so our 12 pieces was multiplied by 20. That's why we've got this 240 pieces. So this 240 pieces is good for the 20 footings. So the total length of all the bars, so this is actually the total length of all the bars. So this 240 pieces was multiplied by the net length of our reinforcing cut bar. So we have 1.20. So 240 multiplied by 1.20 is 288 meters. Then step number 5, the last step, is to divide the above result by the length of one steel bar. Say, okay, so let's say 6 meters. So 2.88 was divided by 6, so we have 48 pieces. So we have 48 pieces of 12 millimeter by 6 meter steel bars. So solving the same problem by the first procedure, net length of one reinforcing bar is 1.20, and then the total bars in one footing is 12 pieces. Total for 20 footings is 250 pieces, and then divide one steel bar by the length of one cut bar, so we have 5 pieces. So this simply means that 5 pieces at 1.20 meter long reinforcing bar could be taken from a 6 meters long steel bar. Then divide the total cut bars for 20 footings by 5. So we have 240 divided by 5. So we have 48 pieces. So the question now is when to use the first procedure and when to adopt the second procedure. So I think all of us will get confused if when will we use the first procedure and then the second procedure. So here, in determining alone what procedure to adopt is an additional burden. To avoid such confusion, the following rules will help in making the right choice. So we have rules on how or when we are going to use the first procedure and then the second procedure. So here are the rules. First is to determine the length of one reinforcing bar. So after determining the net length, we will divide it by 6 or any commercial length steel bar by the result of step 1. Step 1. So this 6 meter is dependent only if what is the commercial length of the steel bar. So if the result is a whole number, so let's say we have 10, so that's a whole number, that's an exact value, so we will use the second procedure. But if we will get a result of a fractional value like 10.4, 10.6, so we need to adopt the first procedure. So considering illustration 3.5, tie wire could be determined under the following steps. So this is actually, we'll just use this illustration again. So find the number of bar intersections in one footing. So we have 6 by 6 times 6, so we have 36 ties. Then total ties for 20 footings, so we have 36 ties and 20 footings, so 20 was multiplied by 36, so we got 720 ties. So we have 720 ties for 20 footings. Using 25 centimeter length per tie, we will multiply 720 by 0.25 meters. Since 25 is centimeter and we will converting that into meters, so we've got 0.25 meter. So when it was multiplied by 720 meter, so we have 180 meters. So 1 kilo of a number 16 GI wire, I'm not really particular in the price of mga wire, but here it was approximated that it is 53 meters long. Yeah, 53. Okay. So I mean, not the price, but the 1 kilo of wire is approximately 53 meters. I'm sorry. So we'll just divide the 180 meters into 53. So we need 3.4 kilos. Okay. So these 3.4 kilos are the tie wires we need to use for the 20 footings. Okay. Post and column reinforcement. So the reinforcement of post and columns to be considered in the estimates. So these are the following we need to consider for our reinforcement of post and columns, since we really need to make our buildings like strong enough to handle our problems, to handle our, I mean, to kanang tupugong bada bagyo inana. So these are the following. First is the main or vertical reinforcement, and then the lateral ties. These are actually for the column or beams, and then the spiral ties for circular column. I think all of these are familiar to us. So the quantity and length of the main reinforcement is determined by the direct counting method, giving special attention to the additional length for excuse me. So first is the lap joints of end splices. It's here. Then second is the allowance for bending and hook. We can find it here. This is our column, this is our beam, and this is our slab, the floor slab. So, and then the third one is the additional length for the beam depth and floor thickness if the height of the building plan indicates from floor to floor. So this is the additional length. Kaya yan what we call this one, point out. Okay, beams and girders reinforcement. The direct counting method is the best method in determining the main reinforcement for beams and girders, provided that in the selection of the length of steel bars, the following physical condition of the beam in relation with its support should be considered. So these are the following we need to consider. First is to verify from the plan if the span of the column where the beam is to rest measures from center to center. So this is the example. From center, this is your beam, and then this is your column. So from center to center. Okay, or outer to center. This from outer, okay, where it is. Okay, from outer to center. And then outer to outer side of the column. Okay, outer to outer side of the column. This is to be considered in determining the length of steel bars to be ordered. Okay, so the second one is to verify. We really need to verify the position of the reinforcement splicing if it is adjusted to the commercial length of steel bars. The lesser the splice, the lesser the expense. So kanang as a future engineers or future kanang mag-solve sa mga cost, as engineers we really need to minimize the, like kung mahimo kay katong the best nga mga kuan, the best nga mga, what they call this one, mga the best nga mga steel bars kumbaga, but kana po makasave pud ta. So then the third is to identify the bars with bend and hook for adjustment of their length in ordering the steel bars. Okay. So this is the actually the span of the beam. Okay, lateral ties. Tied column has reinforcement consisting of vertical bars held in a position by lateral reinforcement called lateral ties. So these are actually the the one you need to hold the steel bars. You need these ties. So the ACI code so provides all non-pressed all non-pressed bars for tied column shall be enclosed by lateral ties of at least number 3 in size for longitudinal bars number 10 or smaller, and at least number 4 in size for number 11 to 18 and bundled longitudinal bars. So the spacing of the ties shall not exceed this. First is the 16. The longitudinal bar diameter dapat dili siya mag-exceed sa 16. And then the lateral tie bar diameter dili siya mag-exceed sa 48. And then the least dimension of the column. So first illustration for the lateral ties. Determine the spacing of the lateral tie for a tied column. That's shown in figure 3 to 11. So this is actually our what do you call this one? This is our lateral ties with 10 millimeter. And then this is our column reinforcement. This is the dimension of our, dimension, which is 30 centimeter by 30 centimeter. Okay. So our problem is to determine the spacing of the lateral tie for a tied column as shown in figure 3. So first step, okay. Diameter of the main longitudinal bar is 20 millimeter. Then next is the diameter of our lateral ties is 10 millimeter. Okay, so this is the diameter of our longitudinal bars. And for the lateral ties, this is actually our diameter. So we will multiply 16 by 20 millimeter. So we have 320 millimeter. So this is actually the one I've mentioned here. It was mentioned here. The longitudinal bar must be multiplied by 16 Okay. I'm sorry, but I will repeat this. So the spacing of ties shall not exceed. So 16 multiplied by the longitudinal bar diameter, and then 48 will be multiplied by the lateral tie bar diameter. So murag na mali ko ganina sa akong giingon diri. Sorry. So okay. So let's continue. So we have 20 millimeter and then 10 millimeter. So this is our longitudinal bar. So as it was mentioned that we will multiply this by 16 and then this lateral ties by 10. So we have 320 millimeter and 480 millimeter. So the shortest side of the column is equal to 300 millimeter. So we need to adapt 300 millimeter. So which is 300 millimeter is equivalent to 30 centimeter spacing. So this is the spacing of lateral tie for a tied column, 30 centimeter. Okay, for illustration 3 to 7, a building has a series of 26 square columns having a cross-sectional dimension of 30 by 30 centimeter with 8 pieces, 20 millimeter vertical reinforcing bars for each column. Make an order of 10 millimeter steel bars required for making the lateral ties. So, accordingly, sa problem, they use 20 millimeter. So we will make this into, we will make an order of 10 millimeter steel bars. So this is our column. This is our lateral ties, which is 10 millimeter. And then our column reinforcement is 20 millimeter. And then the dimension is 30 by 30 centimeter. Okay. So again, our 20 millimeter longitudinal ties. What do you call that one? Main longitudinal bar, was multiplied by 16, and our lateral ties was multiplied by 48. So 16 multiplied by 20 is 320 millimeter, which is equal to 32 centimeter, and 48 multiplied by 10 is equal to 480 millimeter, which is also equal by 48 centimeter. So the shortest side of the column is 30 centimeter. So we will adapt this 30 centimeter as the spacing. Okay, so determine the number of lateral ties in one column. Okay, so the height of our column is 7 meter. And then it was divided by 0.30. So 7 divided 0.30 is equal to 23.3 pieces. So the 23 pieces is the distance between the lateral ties. What we need is the number of ties in one column. So we add 1 to be exact. So 23 plus 1 is equal to 24 pieces. Since murag kuan mo pugod ka ng 3, kung may 23.3, imo palugar tong tungaon tong usa, imo mong 0.3, no? So that's why we make this as an exact. We just add 23 by 1, so we have 24 pieces. So next is to solve for the lateral ties of the 26 columns. So we have 24 pieces in every column, and then we have 26 columns man. So 26 was multiplied by 24 is equal to 624 pieces. So we need this 624 pieces for our 26 columns. So next is to find the length of one lateral tie. So by inspection, we have 1.20 meter long. Okay. For the step 7, we need to determine the number of 1.20 meter cut from a 6 meter steel bar. So 6 or 6 meter was divided by 1.20 meter. So we have 5 pieces. So divide the result of 5 by result of 7. So the result of our 5 is 624 pieces, and it was divided by the result of our 7. Step 7, which is 5. So we have 124.8. So we'll just round off this into a whole number. So we've got 125 pieces. So we need 125 pieces of 10 millimeter by 6 meter steel bar. So this is our answer. For illustration 3.8, excuse me. Okay, so from figure 3 to 13, this is our figure. Prepare an order of 10 millimeter steel bars for making the lateral ties. So, okay, we need to prepare an order of 10 millimeter steel bars for making the lateral ties. Okay, so this is the solution. Okay, this problem is an improvement of illustration 3 to 7. Okay, it is actually a what do you call this one? Let's say continuation. Okay, so the outer ties have been found to be 125 pieces for 10 millimeter by 6 meter steel bars. So what is to be determined here is the inner ties. Okay, so okay, I'm sorry, I'm lost. So here, okay, so this problem again is an improvement of illustration 3 to 7, where the outer ties have been found to be 125 pieces, 10 millimeter by 6 meters. So what is to be determined here is the inner tie. So by inspection, the length of the inner tie is 83 centimeter or 0.83 meter. So we will determine how many 83 centimeter could be cut in a 6 meter steel bar. So we will just divide this 600 centimeter into 83 centimeters. So we have 7.23 pieces. So disregard the fractional value again of 0.23. So let's accept 7 pieces. And then divide 624 pieces by 7 pieces. So this is the result. Actually, this 624 actually was the result of our illustration 3 to 7. Okay, I don't have the one number. Yeah, here. This is actually the illustration 3 to 7 here, and we will just add this inner ties. So we already got the outer ties, so we'll just get the inner ties and then add all of them. So we have 624 divided by 7 pieces. So we have 89 pieces of 10 millimeter by 6 meter. Okay. So our total dito sa atong illustration 3 to 7, we need 125 pieces man of 10 millimeter by 6 meter. So we will add this. Mamani atong outer ties dito. We need this 125 lateral ties. We'll just add this. Okay. Steel bars lateral ties. Lagi. So 125 plus 89 pieces of 10 millimeter by 6 meter steel bars there. So we have 214 pieces of 10 millimeter by 6 meters. So that would be all, and thank you.
Good evening. This is Jason Embarcado. My topic for today is metal reinforcement, simplified construction estimate, and I will continue the report of Mr. Kanabe. So we will start. Illustration 3-9 from figure 314, and this is the figure 314, the drawing. Prepare an order of 10 mm steel bars, making the lateral ties, including the tie wire required. So for the solution and process, the given data is number of columns. So this is the given data. There are 60 number of columns and size is 25 by 40 centimeter. Then clear height is 4.6 meters and spacing is lateral spacing is 25 centimeter. So the first part of solution is by inspection. There are three types of tie. In this figure, there are three types of tie: the outer ties, the straight ties, and the inner ties. So the outer ties is 120 centimeter long, and inner ties is 85 centimeter long, and straight ties is 5 centimeter long. And for the second part, determine how many 120 centimeter and 85 centimeter and 50 centimeter long could be made out from one 6-meter steel bar. So convert this 6-meter into centimeter, and that is, for getting the outer ties, that is 600 centimeter over 120 centimeter, and that is 5 pieces. For the inner ties, same process but divide into 85, that is equal to 7 pieces, and for straight ties, divide 50, that is 12 pieces. Then next is to determine the number of ties in one column. So height is divided into the, the spacing. So height is approximately 4.6 meters and spacing is 25, and convert into meters 0.25 meter, and that is 18.4, and rounded up, that is 19 pieces. For the total ties for 16 columns, so 19 pieces of ties is divided into 16, and that is 304 pieces. For the fifth part, divide the total ties of for 16 columns is 304 pieces, and then for the next part, that 304 pieces is divided into 5. Divide 304 by each of type in step 2. So 304 divide 5 equals, that is, this is 5 pieces, 7 pieces, and 12 pieces. And that is 60.8, say 61 pieces, and 304 divided 7 is 43.4 pieces, and 304 divided 12 is 25.3 pieces. 6. For the sixth part, order 130 pieces of 10 millimeter times 6 meter bars. And note, the fractional value of 0.4 and 0.3 was considered as 1, which was included in the order. So solve in the last part, that is solving for the tie wire. Number of joints per lateral tie by direct counting equals 12. Number of joints per lateral tie by direct counting is equal to 12. And number of ties in a column, that is 12 times 19, and that is equal to 228 pieces, and the total wire for the 16 columns is 228 pieces times the number of columns, which is 16, and that is 3,648 pieces. For the 30, multiply by the length of each tie, say 30 centimeter. So 3,640 pieces times 0.30 meters, and that is equal to 1,094.4 meters. And then for the 30, divide by 53 meter length per kilogram. So the result is 20.6. By rounding it up, it says 21 kilograms of number 16 wire. Next is for stirrups for beams and girders. Stirrup is the structural reinforcing member that holds or binds together the main reinforcement of a beam or girder to a designed position. There are two types of stirrups commonly used are closed stirrups and open stirrups. Figure 317, a problem. The problem is a concrete beam with a cross-sectional dimension of 25 by 40 cm requires 10 mm open stirrups spaced as shown in figure 317. Prepare the order of 10 mm steel bars for stirrups of 8 beams with the same category, so there are 8 beams. And for the solution, by direct counting, there are 24 stirrups at 90 cm, say 1 meter long. Total number of stirrups is 28 stirrups times beams, which is 8, and that is 192 pieces. Referring to table 3.6 for 1 meter, long stirrups using a 5 meter long steel bars. Divide 1 into 2 pieces by 5 meter, and that is 38.4 pieces. 10 millimeter by 5 meter. Using a 6 meter long steel bars, divide 192 over 6 equals 32.0 pieces by pieces 10 millimeter by 6 meter. And the order is 32 pieces 10 millimeter by 6 meter steel bars. Next is spiral and column ties. Spiral and column ties consist of evenly spaced continuous spirals held firmly in place by at least 3 vertical bar spacers. The clear spacing between the spirals should not exceed 7.5 cm nor less than 5 cm, or 1/2 times the biggest size of the coarse aggregate or gravel. And another problem: a spiral column with a cross-sectional diameter of 50 cm requires 10 mm spiral reinforcement as shown in Figure 3.18. If there are 14 columns at 7 meters high each, find the number of 10 mm steel bars needed for a 5 cm pitch. So the solution for letter A, spiral reinforcement. First is to find the total length of the 14 columns. So there are 14 columns and its length is 7 meters. So 7 times 14 is equal to 98 meters. Then from table 37 for a 50 centimeter column diameter, 5.00 centimeter pitch from the table, multiply 98 by 3.233, and that is 316 pieces. And the order is 316 pieces, 10 millimeter by 9 meter steel bars. For letter B, the tire wires, find the number of vertical bars per column cost by referring to table 3-7. Table 3, this is the table 3-7. For a 5 centimeter pitch, multiply 12 times 21 turns per meter, that is 252 ties total tie. Where for 14 column bars intersections at 7 meter height, and that is 252 times 7 times 14 is 24,696 pieces. Total length of the wire at 0.30 meter long per tie wire is to multiply the total tie wire by 0.30, that is 7,409 meters. Convert to kilogram at 53 meter long per kilo, divide 7409.53, and that is 140 kilos. And this is the table 3.7, which is the basis in this problem. Spiral column. Metal reinforcement table again for simpler solutions and calculations. One-way reinforced concrete slab illustration. From the figure 3-19, this is the figure 3-19. Determine the number of steel bars required, including the tie wire. So, solution. For the given data, spacing of main reinforcement is 150 mm, 0.15 meters. Spacing is 0.15 meters, and temperature bar spacing is 0.25 meter, and size of the reinforcement is 13 millimeter. Type of reinforcement is one way. This is the figure 3-19. This is the first part for the given data, and for the second part is determine the number of main reinforcement. That is 4.70, which is the one-way slab. 4.70, which is one-way slab over the distance. Spacing of main reinforcement, which is 0.15 meters. Plus one, that is 32.33 pieces, 5 meters steel bar. And note, in dividing the length by this bar spacing, what is found is the number spacing. Add 1. Therefore, we must add 1 to get the number of bars. Determine the length of the cut bars alternate to main reinforcement. That is 1.075 plus 0.75, which is the hook, and is equal to 1.25 meters. 1.075, the distance of cut bars. Then for the number 4, using a 5 meter steel bars, 5 meter all over length of cut bars, that is 4 pieces number of cut bars in one steel bar. And for the fifth part, divide step 2 by step 4. So step 2 is 32.33 pieces divide by 4 pieces, and that is 8 pieces, 5 meters steel bar. Metal reinforcement for 6 part. Total main reinforcing bars is 32.33 plus 8, that is 40.33 pieces. Solve for the temperature bars at 2.15 meter span. 2.15 over 0.25. 0.25 is the temperature bar spacing. Plus 1, that is 9.6 pieces. Temperature bars at 1.075 span, and that is 5.3. Multiply by 2 layers at 2 sides, that is 5.3 times 4, and that is 21.2 pieces. And result of 6 and 9, that is 9.6 plus 21.2, that is 30.8 pieces. And the total summary of 6 and 10 is 40.33 plus 30.8, that is 71.1 pieces, 13 millimeter by 5 meters steel bar. And there is also another solution, which is by the area method, which is much simpler with two processes. Solve for the area of the floor, that is 4.70 times 4.30, that is 20.21 square meter. Then for number 2, referring table 3.8, so 3.8 is not included. So in table 3.8, using 5 millimeter at 150 millimeter spacing, multiply 20.21 3.524 equals 71.2 pieces. Two-way reinforced concrete slab. So Frena is one way, then ngayon naman is two-way reinforced concrete slab. From figure 320, this is figure 320. Determine the number of 13 mm steel bar and tie wire required. So the two-way slab, the distance is 7.20 meters. Solve for the main reinforcement. Reinforcement is the main reinforcement, the distance is 3.6 meters at the middle. All over 0.10 plus 1, that is 37 pieces. There are two-way run, and therefore we must multiply the 75 into 2. That is 74 pieces steel bars. For cut bars at 1.87 long, there are 4 pieces. There are 4 pieces cut in one 7.50 steel bar. So 74 over 4, that is equal to 18.5 pieces steel bars. For temperature bars at 1.80 meter span, 1.80 divide 0.25 plus 1 is equal to 8.2 pieces. Then for the fifth part, multiply by 4 sides at 2 layers because there are 2 layers. So 8.2 times 8, that is 65.6 pieces. For number 6, summary total of step 2, 3, and 5. And that is for the first part 72 pieces plus 18.5 pieces plus 65.6 pieces without number 4, that is 158 pieces. For the second solution by the area method, area of the floor slab is 51.84 square meter, referring to table 3.9 again. It's not included. For in this PowerPoint, for 7.50 meter steel bars at 100 millimeter spacing. The area of the floor slab is divided into 3.050 equals 158 pieces, and order is 158 pieces, 13 millimeter by 7.50. This is table 3.8, quantity of steel bars and tie wires in one-way reinforced concrete slab, which the table that is being used in this problem. Then next problem is concrete pipe reinforcement. From figure 321, solve for the steel reinforcement using 10 millimeter and number 16 tie wire. And first is solve for the circumference of the circle at midpoint of the concrete T. Circumference is pi times diameter. So diameter is equal to 0.90 plus 0.10. So circumference is equal to 3.1416 times 0.90 plus 0.10. That is 3.1416 meters. Circumference is equal to 3.1416 meters. Total length of one ring at 0.15 meters splice 3.1416 plus 0.15 equals 3.29 meter. And for the third one, find the total number of ring at 0.20 centimeter, OC. 1 height over 0.20 equals 5 plus 1 to get the total number of ring equals 6 pieces. 6 pieces. Then for the fourth one, temperature bars at 0.25 meter, OC. And the temperature bars is equal to 3.1416 over 0.25 equals 12.56 says that is 13 pieces at 1.00. For the tie wire, the number of ring multiplied by the number of temperature bars is 6.13 equals 78 pieces at 0.30 meter long per tie wire. Then the total length is 78 times 0.30, that is 23.40 meters. Then for the third one, divide by 53 to find the weight in kilogram. So therefore, 23.40 over 53 equals 0.44 kilos, number 16 tie wire. And this is the table 3-9, quantity of steel bars and tie wires in a two-way reinforced concrete slab. This is a one-way reinforced concrete slab and two-way reinforced concrete slab. These tables are very useful in calculation and much easier to use because of the data that are being plotted. So concern lang po sa among report sir is ang time. So kulang nang lapas mi sa time. Amo na siyang gidala mo report but then lapas gyapon. So dili ka na ma-elaborate among report tungod kaya ginapas sa mga time. Pero thank you sir. I hope nga na-explain ang magtarong mong report bisan tuwid kulang. Walang sir, salamat kay sir. God bless you. Thank you.